Hi and welcome to Sprite tutorial number 2. In this tutorial we will approach movement and placement of our sprites in a different way. Previously we just placed the sprite at the coordinates of the mouse, and before that we just manipulated the coordinates of the image and moved that around the screen. This time we're going to use rotation and movement to create a game style closer to that of the Atari Classic Asteroids. Sorry, I used to own Atari ST, so whenever I say Atari, that's the first thing that pops into mind. But of course, that wasn't the first machine Atari turned up on. Anyway, some errors I made in my previous tutorial. In the previous tutorial, I made 2 errors in the source code that might cause you some problems. First of all was the command backdrop on. This needs to be removed from the program completely, and draw sprite first needs to be added just before your do and loop commands. Backdrop on is really for 3D data so that it doesn't blur. With a sprite based backdrop we don't need it, and it does cause some draw order problems that I've noticed. Draw sprites first changes the order of which the Dart Basic Professional compiler handles the sprite drawing. When dealing with sprites on top of 3D space, you need them to be drawn last, so that if you're producing an overlay to a 3D scene, all the sprite data will appear on top of your visual data. However, we're working exclusively with sprites in this tutorial, and I'm going to take the approach that you're going to be doing the same. And we need to do things like display diagnostic data on top of the sprite background. You'll notice in the previous tutorial that the paste sprite command basically didn't move the sprite around the screen as we wanted. We had to use the sprite command instead. There is a paste sprite command that you can use as well that doesn't require you to alter or change the sprite in any way or update the image or anything like that. But the trouble is it was being drawn behind the backdrop. By adding this command before your do and loop cycle, you will basically allow the sprite to be drawn on top of the background instead. So it basically resets all the drawing order. It also means that we can draw things like boxes, dots, squares, text, that kind of thing on top of the sprites as well. So if you have any need for those or they're not showing up in your games, that would be why. So by changing the backdrop on and adding the oops, sorry, my brain's gone blank. The draw sprites first command. By adding the draw sprites first command before the do and loop sequence, we'll ensure a proper draw order and everything will display correctly. That is until I make another mistake and have to update it in the next tutorial. But never mind, no one's perfect. So anyway, let's get on with our new source code. I'm going to type out all the source code in these tutorials because I'm not going to assume anyone's followed the previous tutorial, so I'm going to start off with the bulk of the tutorial programming first. However, if you've still got the previous tutorials, you can also edit the source code if you don't fancy all that typing. There will be bits that are the same. So type objects, x as integer, not strictly speaking needed, because anything without a symbol, string or hash would automatically be treated as an integer, but I prefer to set it up for my own peace of mind, which I think I said in the last tutorial as well actually, so that shows you how much I mean it. So id as integer as well. We're also going to have r as integer, h as integer, w as integer. I'll just quickly explain what all these mean. Of course, we also end this with an end type. Now, X is the X position of the screen, Y is the Y position of the screen, ID relates to both the sprite and image ID, so you'll be serving a dual purpose. R means rotate, or stands for rotate, which we will be using this tutorial. H stands for height, that's used in the offset commands, also discussed in the previous tutorial, and width is the width of the sprite, and again that is also used in the offset. Now I need to set up a few parameters. So global background as objects, global player as objects, and we're going to set background .id equals 1 and player.id equals 2. Now there's a little bit of change in this next block of code. It's changed from the previous tutorial, so we're going to use the sync on as we did before, then sync rate 60 as we did before. Now we're skipping the backdrop on command and we're just going for auto cam off. I don't actually need that command in there either, but it's just habit, so I'll leave it in there. Load image, open quote, media / backdrop.png. I'm going to assume you've already downloaded these files. If you haven't, then you'll need to look in the descriptions of my previous 2 tutorials for the download link. So these are PNG files pre-formatted with transparency, ready for you to use, or of course you can create you can create your own. If you watch the tutorial 0, I showed you how to do that as well in GIMP. Okay, so we're going to assign it an ID of background.id, so that's automatically been assigned as 1. Load image, open quote, media / ship sprite1.png, close quote, comma, and of course we're going to give it the player.id, which is number 2. Now we're going to find the center of the screen, and we're going to ensure that our player object is placed there to begin with player.x equals screen width, open parentheses, close parentheses, divided by 2, and player.y equals screen, I think it's height, yes it's height, open parentheses, close parentheses, divided by 2. Now we're going to set up our sprite background, so sprite background.id, 0, 0, and a background.id. If you don't know what that does, then look up my previous tutorials, I've already explained that. Sprite player.id, player.x, player.y, player.id as well. So as you can see, we're centering our sprite to the middle of the screen. Now we're going to get some more data. We need the height and width of the sprite as well. So player.h equals sprite height, open parentheses, player.id, close parentheses, divided by 2. Player.width or .w is going to be sprite width, open parentheses, player.id, close parentheses, divided by 2 as well. And of course we're going to do the same as we did last time. We're going to offset the sprite, and this ensures that the middle of the sprite is placed at our coordinate set, rather than it being placed at the corner or the top left-hand corner of the sprite, which is what happens if we don't offset it. So offset sprite player.id, player.width, player.height. Now we're going to add in one of the new commands, which is draw sprites first, And we're going to create our do, sync, and loop sequence. So do, sync, and loop. Oh, it seems I put a space all the way along there, but never mind. Won't affect the code's operation. It's just a bit untidy. And now we're going to bring the first command of our series. But before we do that, we're just going to compile this program just to make sure I've made no mistakes. So yes, we're exactly where we were before. We've got the sprite in the middle of the screen, and we've got our backdrops. So the two commands we've changed haven't altered the results. They've just altered what's going on in the background, and it will make things a lot easier in the long run. So we'll close that down, and now we'll add in if space key open parentheses close parentheses equals 1, then move sprite player .id, comma 2. So now if we press the space bar, all it's going to do is move the sprite forward. Now you'll notice it's not playing with the X and Y axes at all. This is very much like the 3D command move object. It pretty much, well no, it works in exactly the same way, it just doesn't have the Z axis. So whichever direction the sprite is facing, that's the direction it's going to go. So if we compile this program and press space, you'll see our ship is now flying off the edge of the screen. And so now we've just handled it in a completely different way. We haven't used paste, we haven't worked with any of the coordinates, we've let Dark Basic Professional do all the work for us. It's worked out the X and Y position itself, and it's automatically placed the sprite at that location. So now what we're going to do is add some rotation to it, so it looks more and more, or ever increasingly, like Space, sorry, not Space Invaders, but Asteroids. One of those Atari classics anyway, you know what I mean. So player.r equals 0, so we're ensuring that the rotation is set to 0. Don't actually need to do this. It should automatically assume it's 0 already, but it's just something that helps me follow the logic so I know what's going on in the program flow. And now we're going to type in the commands. If left key open parentheses close parentheses equals 1, then deck player.r, and you can guess what that's doing. It's reducing the number in the player.r. So if it's 0 and it decreases, it's going to be -1, -2, -3, etc, etc. So we're basically adjusting the value of the rotation. Now remember, this is rotation in terms of a circle. If you have 0 degrees, then your ship is going to be pointing upwards at 12 o'clock, and as you increase the number, the ship will turn, and I will show you that in action in a moment. So if right key, if I can actually spell today, open parentheses close, there, open parentheses close parentheses equals 1, then inc player R, so we're going to increase the value so we rotate in the other direction. And now the magic command that makes it all happen: rotate sprite player.id, and we're just going to assign it the value player.r, and that's all we need to actually make our sprite rotate. So we're going to compile that program now. We've got our ship in the middle of the screen, and I'm holding down the right key and it's turning right. If I hold down the left key, it will turn left. So there we go. We've now got a ship that looks very much like something you would find in Space Invaders. And of course, I keep saying Space Invaders, I mean Asteroids. So it's very much like a ship you might find in Asteroids. Now, of course, if you hold down the space key, it moves in that direction. And if we hold down the space key and orientate it another way, all we're doing is moving the sprite, and it's moving it in the direction as it moves. Now this is a vast improvement over using images, I think you'd agree. It's treating it almost like a 3D object. Well, no, it's treating it like an object, because an object simply means something that can be manipulated and used in this way. And these commands basically make it very easy for you to fly around the screen in a nice asteroids kind of fashion, like so, simply by holding down the space key to go forward and the rotate keys to turn your ship. So I think you'd agree that's a nice and simple and a very easy way to start controlling your player's ship. So now what do we need to do? We need to actually have a look at the data that's going on in the background, and there is a method to my madness. Now you'll note that the draw sprites first is there. Now if I type in text 10, 10, open quote, rotation, colon, there's a colon, yes, sorry, mine's going blank again, doing too many things at once, close quote, add string, open bracket, player dot r, and close parentheses. I keep swapping between brackets and parentheses, but they both mean the same thing basically. Now if you don't know what the string command is doing there, I have uploaded a tutorial which turned out to be shockingly unpopular, which taught you how to convert values into strings and strings into values. So that's what that's all about. So if you want to know what that command's going on and how to do all that, then you can go back and watch probably one of my least watched tutorials ever uploaded, but never mind, these things happen. So if we compile the program, you'll notice now we have a nice rotation indicator at the top of the screen, but it's going up and up and up. So as I rotate my ship, it's just continually rotating. Now if you're going to be dealing with objects at a data level, which many things are going to be, then you're going to have quite a lot of confusion. So what we really want to do is just deal with the 0 to 360 or 0 to 360 degrees threshold, rather than going up with all these ridiculous numbers. Apart from anything else, even though we do have it set to an integer, if someone was to hold their finger on this long enough, it would eventually go the entire spectrum of the integer and all the way to the other side, which wouldn't be too good, and it's probably using up way too much memory. So it's good practice to try and limit it. And the way we're going to do that is we're going to use the wrap value command. But before I do that, you'll notice that I've just commented out the draw sprites. You'll notice it's now green. So I'm just going to show you why we've put that command in there. I will now compile the program. Now you'll notice our text isn't there, even though the order of the commands is like that, and it's the last command in the sequence. You'll notice that it's not actually drawing, but as soon as we enable that command, of course, the rotation works just fine. The other thing I'm going to show you is why I disabled or removed the backdrop on command. So if we type in backdrop on here and we compile our program with no other changes, you'll notice that we've got the text, but we've got a blue screen. And the reason for that is because we use the command draw sprites first. It is, of course, doing exactly what we asked it to. It's drawing the sprites first. And then the backdrop on, which is a 3D background setup, so it's designed to be used in 3D space to stop blurring and all that kind of lovely stuff, is actually being drawn on top of our sprites. So the sprites are still there in memory, and they're still being drawn. It's just going in the order of sprites, 3D, then the text data. So that's no good. We don't want that. So if we take our program back to a working version by getting rid of the backdrop on and compiling again just to make sure it still works, as you can see, now we've got our program working as it should. But now we're going to wrap our data to make it a little easier to handle. This will be very useful as you're dealing with angles and firing bullets and things as well. So we want to limit the numbers there. And we're going to do this with a simple line, which we're going to add after the if write key. And we're just going to type in player.r equals wrap value, open parentheses, player.r close parentheses. So all we're doing is we're saying player.r equals player.r within the confines of the wrap value command, which basically ensures that no value will go below 0 and it will not go above 360, maybe 359. I'm not actually entirely sure. We'll find out in a moment. So anyway, if I now rotate this ship all the way around, yeah, I think it's 359 actually. So it's 0 to 359. So there you go. 0 is 12 o'clock there. And if we rotate it all the way around, I'm not doing anything else on the keyboard but holding down the arrow keys, it automatically resets back to 0. And of course, if we go in the other direction, it again wraps it back up to the topmost value, which is 359. So there we go, we've got 0 to 359, which is a common theme in programming. Remember, things like arrays will start at 0, and many other things will as well. So that's a mindset worth getting into. 0 is counted as a number or a slot. So there we go, we've got our ship moving around, we've got our rotation working, and all we need now is a few asteroids, some collision commands and detections, and we'll basically have a working game. So that's how you start rotation, and that's the second way of controlling your ship around the screen. You can adjust the speed and things yourself, and you can just have a bit of fun playing around with it, I should say. So I hope you've enjoyed this tutorial. The next tutorial will be available after the 5th of August 2011, where we will look at some of the other things we can do with sprites. Again, if you've enjoyed this tutorial, please rate, comment and subscribe to my channel. Thank you for watching.